afternoon, everybody. My name is Kevin. As Izzy stated, I'll be presenting my work on profiling the laminar boundary layer on a flat plate in hypersonic flow. This work is important. It's good for informing hypersonic vehicle design, and what we're doing in this experiment specifically is providing CFD validation, and we're presenting to them an experimental data set for CFD validation and development for an in-house robust solver, CFD, of course, being computational fluid dynamics. Data sets like these are sort of uncommon in the public domain, especially in the laminar region of the boundary layer. Boundary layers, of course, being an important part of flow, specifically with drag, and especially important in hypersonic flows where you can have shock and boundary layer interactions. So for this, we are conducting the experiment in the UTSA Mach 7 hypersonic wind tunnel facilities at Week 2. For this, I used two high-speed Schlieren imaging cameras. And you can see the Schlieren image here, the bright white line. That is our boundary layer. And what we're doing is we're actually inserting a pitot probe with a high-speed pressure transducer into the laminar boundary layer. And we're going to be collecting what you can see here in this cutaway, which is called the Blasius velocity profile. That right there is the flow velocity drops to 0 on the plate surface and increases to free stream velocity as it raises above. So we are trying to recreate that and make sure that it's there, that it looks the way we expect it to. So this is an ongoing experiment. So the pressure data, we're not there yet, but we're very close. You can see in the upper right-hand picture, this is the theoretical. This is what we expect. So we're about 50 millimeters from the leading edge of the flat plate. At this point, we expect to see a 3 millimeter thick boundary layer. And that is all determined by our Reynolds number. So that's our sort of determining factor in this. So you can see it's not on the slide, but our boundary layer actually looks a lot like we'd expect it to. The dimensions look about right. And as soon as we have our pressure data, we can verify and provide the data for our CFD friends.